This is section 1.3 of college algebra / pre-calculus. And we're going to be interpreting graphs of functions, part 1, finding values and characteristics of functions from a graph. So first thing, if you have the statement h of 3 equals 2, what does that mean? Well, this 2 here is your y value, and this x that you're plugging into the function, 3, is your x value. So that means that when x is 3, the y value is going to be 2. Super important to know that you're plugging in the x value here, and the result is a y value. So looking at this first example, find each of the following functional values using the graph. F of x is the dashed line. G of x is a solid line. So for whatever reason, in my brain wants to think that f is the solid and g is the dashed, even though it doesn't say that. I don't know why I feel that way. So I'm going to go to my graph, and I'm going to clearly mark that the dashed is f. And every time that these interchange from being, every time they intersect, I'm just going to keep marking it as being f. This helps me when I do the problem. I suggest you do the same. And the red graph is g, which sometimes is above and sometimes below f. All right, now that I got that done, and I think that's important, it's not required for you to do, but it's encouraged. This says find f of -1. That means we start at the origin, we go left 1, and we move up and down until we hit graph f. If I go up until I hit the dashed f, I'm going to land here at 6. So then we're saying 6. This can be interpreted as, on function f, when x is -1, y is 6. It's the ordered pair, -1, 6. Next we have f of -9. So I start at the origin, I go left 9, f is above. If I go up until I hit f, I can see here, if I look closer, there's an open circle here when x is -9. An open circle means that the point gets really, really close to that value, but never actually touches it. So what that means is function f is not defined when the x value is -9. I'm just going to get rid of this equal sign, and I'm going to say f of -9 is undefined. We would never want to say equals undefined. And if you notice that on any of my answer keys, let me know so I can fix it. Because I used to incorrectly say equals undefined. That is wrong. I should not be saying that. F of 5 is the next one. So if we go from the origin and we go right 5, this time we have to go down to get to f, so our answer is going to be negative. That's a y value of -5. So f of 5 is -5. That's the ordered pair 5, -5 on the dashed graph. You're going to hear me say things like curve, function, graph. Those are all synonyms. Even if it isn't technically a curve, it's linear, we still can put that under the umbrella of being a curve. It's just it's a general term for a graph. Now we're at function g. So function g is this red curve here, and it says g of -3.2, and then it says is approximately. This symbol here means what is the approximation of -3.2. Start at the origin, we go left 3.2 is about here. We go up, we're someplace above 1 and below 2. Looks closer to 2 than 1. I'm just going to say that this is about 1.8. Now, this is a great time to say that in this class, we always round to 3 decimal places. Always. I will say that a lot. That's because the AP exam does that. So just to be adorable, I'm going to make my 3 decimal places, let's say 1.825. That's an approximation. I don't actually know what the actual value is. It's a good guess. If we put some more effort into it, we could find the actual number, but it says to approximate, so we're going to take the easy way out and approximate. This next one is a calculation to do. F minus g of -3. what that means for us to do is to figure out what f of negative 3 is, figure out what g of negative 3 is, and then subtract those results. X value, the result of this is a y value, or the result of this is a y value. So if I go to my graph, f of negative 3, that's the dash curve, that's a 6. And I go back to my graph, g of negative 3, that has a y value of 2. So this is 6 minus 2, which is 4. So f minus g of negative 3, I'm getting a little sloppy. When I get into a hurry, oh geez, I'm sorry. When I get in a hurry, I write poorly. And then as a result of writing poorly, I have to erase it and write it again, which means I get punished and it takes longer when I was trying to save time. All right, let's look at this next one. This next one's right here. And a common mistake that my brain wants to make is think this is problem number 2. It isn't. It's 2 times f of negative 4. So we're going to end up taking 2 times whatever this answer is minus whatever this answer is. I'm just going to kind of put a shell of it here of what I'm going to be doing. So it's 2 times a number minus a number. And for giggles, I'll put parentheses for both of those answers. So what's f of negative 4? Over here is negative 4. F is the dash. That's 6. Well, we have used that 6 a lot. And then minus g of negative 6. Here's negative 6. For g, that's a negative 2. To be clear, this subtract is what this subtract is. This is a negative 2 because it went below the x-axis. So subtracting a negative is like adding a positive. So this is equivalent to saying 12 plus 2, because 2 times 6 is 12. That sum is 14. In the perfect world, we would write this again down here. We don't live in a perfect world. This next one is a fraction. That just means divide. So we're going to end up with a couple numbers up top that we add together and then dividing it by a number on the bottom. So g of negative 8, I go left 8 and down 2. It's going to be negative 2. You could put that in parentheses or not. It's not super important. And then f of 0, that's the y-intercept for the dashed curve. That's a 3. And then dividing by g of 0, that's the y-intercept of the solid red curve. That's a 4. Negative 2 plus 3 is 1, so it's 1/4. There's no need to make it into a decimal. If you chose to, do it to 3 decimal places. Next one, we are multiplying a negative 2 times g of 8 and subtracting 3 times f of 17. I'm just going to put a shell over here so I don't forget numbers. I just moved over the negative 2 and the subtract 3, and then I left blank spots for g of 8 and f of 17. G of 8, that's easy. I go to 8, I drop down, that's a negative 2. F of 17 is anything but easy. Because if we look at our graph doesn't even go to the right enough to be able to easily tell what that is. However, as discussed previously in a different section, if your graph stops at the end of the coordinate plane, the assumption is it's going to continue. As opposed to G here, there's a closed dot, so we know that ends. We're assuming, rightfully so, that this F graph continues as a line forever as it goes to the right. So to figure out what's happening at 17, let's examine the slope. If I'm on this curve, every time I go up 1, I'm going to go to the right 2. So that means my slope is going to be a positive 1/2. So right now, I'm trying to get to 17. I'm at 11. at this point here. If I go up 1 and to the right 2, that's going to put me at 13. If I go up 1 and to the right 2, it's going to put me at 15, 0. And if I go up 1 more and to the right 2, that's going to put me at 17, 1. Another way to look at it, oh, there's lots of ways to look at it. I won't bore you with it. But the point is that f of 17 is 1. So in simplifying this, negative 2 times negative 2 is 4. A minus 3 times 1 is a minus 3. 4 minus 3 is 1. So, finished. All right, let's come down here. Now, this is asking a different type of question. All of the questions up here gave you x values and you were trying to find y values. These questions are asking it differently, and you might want to in your notes. It's up to you. Try to separate these problems because it's something different happening here. If you think that's not necessary, then don't do it. So this first one says, find values of x such that f of x is negative 6. So this is saying that y is negative 6. It's asking us to find the x value. If that's super obvious, don't write that down. So I go up here to my graph, and I find the y value of negative 6. Where does that intersect the dash curve? It intersects right here at 3. So the answer to this is simply x equals 3. Not so bad once you understand what it's asking. This next one, what's the x value when y is negative 3 for graph f? Negative 3, if I draw a horizontal line through y equals negative 3, touches f twice. Touches it here when x is 2, touches it here when x is 9. So I'm simply going to say x equals 2, x equals 9. Got both of them. Next one, a little bit different. F of x is 6. Doesn't appear to be different. When you look at the graph, f of x is 6 an infinite number of times. It's equal to 6 from negative 6 to negative 1 inclusive. So all the points between them. To write that, we would simply do a bracket from negative 6 to negative 1. Another bracket, that means it includes the numbers. If these were open circles here, we would use parentheses. Now you might think you're finished, but we have to remember about this little fellow over here. This little fellow over here continues to go up and to the right forever. So it stands to reason that it's going to eventually get to 6. See if we can find an efficient way to figure out what the x value is going to be. Every time, let's see, we ended up at 17, 1. Every time we go up 1, we're going to go to the right 2 because the slope's 1/2. So to get from 1 to 6, we're going to go up 5. If we're going to go up 5, that means we have to go to the right twice as much. We're going to have to go to the right 10. So we were at 17, 1. So if we go, once again, up 5, we're going to have a y value of 6. And right 10, we're going to have a y value of 27 because 17 plus 10 is 27. That's a difficult problem, no doubt. If you're like, I do not understand, I'm having a hard time with that, what you could do is take another sheet of paper and tape it to this paper, and then continue this graph, and then draw this line until you see that it crosses y equals 6 when x is 27. Going back to this answer, so this is an interval. This u means in union with, so this is also part of the answer, 27. Different ways to write that answer, but that's one of the ways you could write it. All right, we got 3 more of these. G of x is negative 6. So if we go down to negative 6, and then what x value has a y value of negative 6 for that graph, None of them. There's no place that this red curve touches that. So we would say this is undefined. G of x is -3. We have a y value of -3. That touches g only one spot. That's right here at x equals 9. I used to be a trucker when I was older, so sometimes the trucker talk comes out. Last one, g of 6 is -4. It's down here. I'm sorry, g of x is +4, not -4. That's up here, and that's hitting twice. When x is 0, and it's hitting over here when x is 4. These problems aren't necessarily difficult to do, but it's easy to make mistakes when looking at a graph, especially when there's two curves on it. All right, let's check out some algebra problems. These two questions here are test-worthy. Now, when I say they're test-worthy, what that means is there's going to be a question on the test with 100% certainty that looks like one of these problems. That's what that means. So mark that in your notes accordingly. So we've got p of x is equal to this quadratic, and then it says for what values of p of x is that equal to g of -3. So let's start out by stating what we know. P of x is supposed to equal g of -3. And then we are told right up here what p of x is. That's x squared plus 2x minus 13. And what is g of -3? Well, this is a continuation of this graph up here. G of -3 is a +2. We're going to put a 2 in for the right side of the equation. This is now an Algebra 1 question. It's not an easy Algebra 1 question, but it is an Algebra 1 question. When you have one variable in your equation and there are different exponents, you want to get all the terms on the same side so it's equal to 0, and you want to factor it. So if I add 2 to both sides to get my constants together, subtract 2 from both sides, I'm going to get x squared plus 2x minus 15 equals 0. Now hopefully you folks know how to factor a trinomial, especially when the leading coefficient's 1. It's pretty simple to do. So long version and the short version. I'm just going to cut to the short version here. End up with two binomials. And if we break apart this x squared equally, that's going to be the first term in each of these binomials. And then we're looking for a pair of numbers that multiply to get -15 and add to get +2. And those numbers would be a +5 and a -3. Let's just confirm. We multiply those together, we get -15. If we add these together, we get a +2. That checks out. If this leading coefficient wasn't a 1, this is a much larger process we need to go through to find this factorization. Once you've got this factored, set each factor equal to 0. Factor just means something that you're multiplying together, and you solve those. And the answer to the question is x is -5 and x is 3. I should say or, not and, or. All right, let's look at Q. It's similar. So we want to figure out what the x value is when Q of x equals f of 5. So I'm going to start out by saying Q of x is f of 5. What is Q of x? It's -3 times the absolute value of the difference of x and 3 plus 4. What is f of 5? I need to use my graph for that. So if I go up here, when x is 5, y looks like it's -5. So that puts us here. Now this is a lot more complicated than the previous problem because of the absolute value. When you're solving an equation with an absolute value and your variables inside of it, you first want to focus on getting the absolute value and what's inside of it by itself. So that means I want to get rid of the +4 and the multiplying by 3. So I'm going to subtract 4 from both sides first. Trying to get the absolute value by itself. Sorry about that. Negative 5 minus 4 is negative 9. Then, to get rid of this times negative 3, I divide both sides by negative 3. I'm going to get the absolute value of the difference of x and 3 is equal to positive 3. Now from here, there's different ways to continue. But here's how I would prefer you think of it. But you can think of it any way you want as long as it's accurate. This absolute value, the difference between x and 3, could end up being a positive 3 or a negative 3. If it's a positive 3, you take the absolute value, you get 3. If this is a negative 3, and you take the absolute value, you get a negative 3. So this could be a positive or negative 3. So long story longer. Once you get the absolute value by itself, remove the absolute value bars, and take the positive number that was over here and make it plus or minus that number. That's how you always do these absolute value problems. Now it's important that you first ask yourself, does this make sense? And we'll talk about that more on another day. But if this part doesn't make sense, there's not going to be any solution to this problem. That'll come up later, we'll discuss. To get x by itself, add 3 to both sides. And I'm going to end up with 3 plus or minus 3. I'm just going to color code here so you know which 3 was which. It's for ease of understanding. We don't want to leave our answer that way. We would like to have definitive answers. So one of our answers is going to be, what if I take 3 minus 3? That's going to be 0. And the other answer is going to be, what if I took 3 plus 3? And that's going to be 6. Whoops. So these are the two numbers that make q of x equal to f of 5. Let's go to the back of our notes. This should go pretty quickly. There's not a lot of calculations to do on this side. Maybe none at all. Comparing function values to 0 and determining when it's increasing, decreasing, or constant. Which variable x or y does the function notation f of x represent? Well, f of x always represents the y value, so that's y. If f of x equals 0, and essentially what we're saying here, we're saying that y equals 0, because f of x and y are the same thing. For a given point on the graph, where is that point located? If I look down here at this graph, if y equals 0, I have to be on the x-axis. That means I couldn't have gone up and I couldn't have gone down. So this point has to be on the x-axis. In other words, we're saying we have some random x value, but we know the y value is 0. If f of x is bigger than 0, remember, this is saying y is bigger than 0, because f of x means y. For a given point on the graph, where is this point located? Well, if y is bigger than 0, that means we had to go up to put a point. So that means we are above the x-axis. If f of x is less than 0, that means y is less than 0. That means y is negative. Where is the point located? Well, if y is less than 0, we had to go down. We are below the x-axis. This stuff may seem obvious, or it may be something you've never thought about before. Math deals with the obvious. That's what makes it difficult, ironically. All right, question A. Identify the interval of values on, that's a typo. Get rid of on. Identify the intervals of values along the x-axis where the graph is, and we got 3 different situations: increasing, decreasing, and constant. Increasing means as you move left to right, the graph goes up. So if I look here, if I move left to right, the graph goes up. From here to here, the graph goes up. Those are the only places. I'm just going to write on here INC for increasing. So the intervals for where this graph is increasing it's going to start at -5 and go to -1 in union with from 0 to 1. Now here's an important point here. These intervals never include the endpoints. Increasing means comparing it from your left and your right, is it going up? Well, at the starting point, if I compare it to my left, there's nothing on the left side. So I can't compare it to anything. If I go to the end point, compared to what's on the right, it's not increasing because what's on the right is lower. So long story longer, if you're asked for intervals of increasing, decreasing, or constant, it's always non-inclusive. This next one, when is the graph decreasing? That means as you move from left to right, the graph goes down. So that's happening here. And that's also happening over here. The graph goes down. Those intervals are from -1 to 0 in union with 4 to 7. Decreasing intervals are never inclusive. I'm going to say that a lot because it's commonly missed. Constant. Constant means you have a horizontal graph. It means as you move left to right, it neither increases nor decreases, it stays the same. This is also non-inclusive endpoints. It's constant from 1 to 4. Now you might look at this and think this is an ordered pair. So I'm just going to write the word interval to avoid any confusion. If you didn't write the word interval, I'm just going to assume you meant it was an interval. So you don't have to write it. All right. Hopefully you know the answer to this question. Should the intervals used to describe if a function's increasing, decreasing, or constant be opened or closed intervals? Well, I said it a couple times already. They should always be open. So increasing, decreasing, maybe I don't need 3 of the 4 letters there, or constant intervals are always open intervals. We'll just say are always open. Intervals is implied. Open means parentheses. Close means brackets. All right, part B, same graph. Identify the x values for each of the following. And I'm going to use a highlighter for this. I suggest you do the same. The first one, f of x is equal to 0. That means that we are on the x-axis. We're on the x-axis at -3, 0, and 6. So this happens when x is -3, 0, or 6. F of x is bigger than 0. We said above, that means we are above the x-axis. So we're above the x-axis from -3 to 0, not inclusive. We skip over 0 because 0 is on the x-axis. We're above the x-axis from 0, not inclusive, to 6, not inclusive. And then part 3, f of x is less than 0. I'll use green for that. Less than 0 means that we're below the x-axis. We're below here, and we're below here. Well, pay attention to this last one because something's going to happen that maybe you didn't anticipate. When are we below? What starts at -5 is -5 included. Is the endpoint -5 below the x-axis? Absolutely. There's a closed dot. So we're going to use a bracket for that. And then once we get really close to 3, but not including 3, we stop being below. And then we pick up again at 6 and we go to 7. And I want to emphasize that 7's included. It's a closed dot. 6 is not, because 6 is on the x-axis, it's not below it. All right, almost finished. Should the intervals used to describe a function as above, below, or on the x-axis be opened or closed intervals? Well, that depends. The intervals might be opened or closed depending if the endpoint is included. Let's write that down. If it depends, why are we writing this down? Feels like no news at all. The reason we're writing this down is we're comparing that, contrasting that with this situation. If you're talking about intervals that are increasing, decreasing, or constant, they're always open. There is no exception. If you're talking about intervals in which the graph is on, above, or below the x-axis, it depends if the point is included. Sometimes they are, and sometimes they're not. Identify the domain of the graph function and the range. Domain are the x values that are included. Oftentimes what I do for this, and this is not required, this is optional, I start on the x-axis where the graph starts. The graph starts at -5, and it includes it. So I'm going to put a bracket here. And if you notice, as we move from left to right, there's no breaks in the graph. I'm now moving from left to right is what I'm doing. If there's no breaks in the graph, then that means the domain is going to be everything along this x-axis until we get to the end of the graph, which is at 7. Long story longer, the domain for this is at -5 inclusive to +7 inclusive. Identify the range. The range is talking about how far up and down the graph goes. So what I do for this, once again, you can do this however you want. The graph goes as low as -4 and it includes it. So I'm going to go to the y-axis and I'm going to put an inclusive -4. It's turned 90 degrees. And then the graph goes up and it gets as high as 4. Every point between them is included. So I'm going to mark my y-axis like this. Once again, it's not required. So my range goes from -4 to 4. Both inclusive. That concludes 1.3 notes. Your homework assignment is homework 1.3. If I made any mistakes on this video, send me a remind and I'll fix it as soon as possible. Thank you very much.